yesterday, and yesterday around 2 p.m. 6 problems are there, and 6 guys can pick. We can go over the last part. This is the vibrating membrane. Now it is not just one string, it's a membrane. And that's why it is in 2-dimensional. It is interesting, really, really interesting. Yes. Theme is exactly same, because I told you that I just try to make your notes in such a way that you cannot make any kind of disturbance or any kind of, inequality, I would say. Yeah, everything that is on the same rhythm. Whatever the things we have started with the heat equation one dimension or wave equation 1 dimension, exactly same thing we did with small changes we did for the heat equation 1 dimension, and exactly same thing with small changes we did for the heat equation 2 dimension. Exactly same thing we are going to follow over here. So corresponding changes are there, otherwise things are almost parallel. But that corresponding changes makes a big difference at the end of the equation. So same over here too. Look at here, guys. Vibrating membranes, 2-dimensional wave equation. We shall now obtain the equation for the vibrations of tightly stretched membrane, right? Such as the membrane of a drum, like this, right? This is just the example, membrane of a drum. Okay, we shall assume that the membrane is uniform and the tension in it per unit length is the same at every point in all direction. Every point, this is the membrane, and tension is same per unit length on every point of the, every point of the membrane. Let T be the tension per unit length. This T be the tension. That means T delta X will be in this and this direction, and T delta Y will be in this and this direction. Okay, so T be the tension per unit length and M be the mass of the membrane per unit area. If we consider the force or forces acting on element delta X, delta Y of the membrane, delta X, delta Y means one cross-sectional area of the membrane. If you divide this membrane into n different parts, suppose the vertical line, and then horizontal line and one square, if you pick, that length is delta X and width is delta Y. So that's what we mean by delta X, delta Y. So consider the forces on an element delta X, delta Y of the membrane due to its displacement U perpendicular to the XY plane. This is my X plane, this is Y plane, and perpendicular. Suppose you have X and Y plane and something is perpendicular to X and Y plane. So plane is like this and something is perpendicular like this from the axis. So perpendicular to the XY plane, the force is T delta Y, that is tangential to the membranes. T delta Y, that is here. T delta Y tangential to the membrane. So tangential to the membrane, that is given in this form, which makes an angle beta over here. And T delta Y on the other side, that makes an angle alpha over here. This is my Y, and this is displacement of Y, there is Y plus delta Y. This is X, displacement in X is X plus delta X. And our membrane, that is, corresponds to this X plus delta X, Y, and Y plus delta Y. So there is like this. This corresponds to this one and this corresponds to this one. That's why I put dotted line over here so that you can understand the things very clearly. Okay. So tangential, so force is T delta Y on its opposite edges. Opposite edges means this one and this one. Opposite edges, that makes an angle alpha and beta to the horizontal. And so that the vertical component, this vertical component that will work like this, T delta Y, T delta Y, T delta Y, and other side it is sine beta. This side it is T delta Y sine alpha. So T delta Y sine beta sine alpha, that is a tangential vector, right? So I can write this one if you divide by cosine. So it is T delta Y and tangent beta minus tangent alpha. Tangential vector, so that's why instead of this one sine beta angle, I think it is better to write tangent. So tangential beta and tangent beta and tangent alpha. And alpha and beta are really very small. This angle is very small. And that's why this T delta Y, this tangent beta, that is a slope. Slope is given by del U by del X. Tangent beta, that is over here. And this corresponds to your X plus delta X. And del U by del Y, this tangent alpha is over here. That corresponds to your del U by del X. So here X plus delta X, and here it is X. Here it is X. If you divide throughout by delta X, that means you are comparing this factor with your rate of change of u, actually rate of change of del u by del x with respect to delta x or with respect to x. So if you divide by delta x, you are comparing your definition, this one with the definition of limit definition of derivative, but partial derivative. So partial derivative that is given in this form, so this will be converted to del square u by del x square. Same way you can, I'm sorry, same way you can work with the other part, this t delta x, this one and this one. So you are going to get t delta x delta y del square u by del y square, because all these forces are working simultaneously in all directions. So right now, just for the sake of convenience, I counted just one direction, but you can count the other direction too. You have to. You cannot ignore that force. So second part is this one, delta square u by delta y square. If you take this one, because now both of them are working over here simultaneously, that means you have to add that one. If you add that one, look at here, as the equation of the motion for the element that is given by mass into acceleration, mass delta x delta y del square u by del t square, and that is equal to this t delta x delta y del square u by del x square plus del square by del y square, right? And if you divide by this m, or m delta x delta y, if you divide by that, that is your just some constant c square, because this is arbitrary small, just small change in x, fixed number, small change in y, fixed number, mass is fixed number, tension is fixed. So these all are constant. So that's why I just would like to put one number that is equal to c square. That is equal to c square. So del square u by del t square, you can see square over here, you can see square over here, and you can see square over here. Both the sides square means wave equation. 1 and 2 dimensions, that's why it is 2 dimensions. See here, it's not just 1 dimension, delta square u by delta x square. Additional factor is the delta square u by delta y square, and that's why it is called the wave equation in 2 dimensions. So please keep in mind this thing, if you are working with just one simple string at that time, it will always provide you a wave equation in 1 dimension. But if you are working with a membrane at that time, like a drama like this, at that time, it will always provide you, means 3-dimensional figure will provide you the wave equation in 2 dimensions. Always keep in mind this thing. The next part is, once you set up the equation for wave equation in 2 dimensions, then after, how can we get the solution of this one? So that's the next part, because that's what we have been doing. That's the same rhythm we are going through. So del square u by del t square equal to c square and this one, and then after we want the solution, because I have the additional factor del square u by del y square, and that's why we are going to consider one more additional factor in my solution supposition. So u x y, that was the previous supposition. In my 1-dimensional heat and wave equation, I supposed u equal to xy. But here I have to have one more additional factor, that is t. Actually, you know this t, here your x and y both are independent. X and y both are independent. And both depends on t. Both depends on. Actually, t is also independent, sorry. U is your dependent variable. But x and y is completely independent over here. Just keep in mind this thing, because t is a time function too. Because I have second derivative over here, so I'm going to take del square u with respect to del t square, right? Del t square means I have second derivative over here. These two remain constant. Then after del square u by del x square means this y and t will remain constant, and second derivative over here. I have del square u by del y square. Y means second derivative over here, x and t will remain as it is. So exactly as it is, just plug the values back in my given equation, and that's what I did. I just divided by c square throughout, because I just want this side without any constant. So 1 over c square xy t double dash, that is equal to this one. Again, previous part we considered some constant, but now we have 1, 2, and 3 factors, not 2 factors. So I cannot say that this plus this equal to some constant equal to this one. I am going to take, if you take the c square over here, and if you divide by x, y, and t throughout, you're going to get just separable variable. I forgot to write it down, separable variable, equation 3. So 1 over c square t double dash over t, x double dash over x, y double dash over y. So it's not just t double dash with x and t double dash over y, it's additional factor x and y. So that's why all these factors, you can consider one constant for this one constant for this one. There may be, it could be same, could be different. So let me consider this one. This will be true only when each member is constant. Of course, each member is constant. And if you convert this one, suppose some additional factor, suppose k, right? This part is some that is equal to some additional factor k. This part is some additional factor with respect to x, it is k. With respect to y, it is suppose L. And with respect to t, it is k plus L. Because k is over here, L is over here. K and L both are related with your T. So T will contain your K and L. Okay, so first of all, let me focus over here. X double dash over X, that is equal to some K, something like that. So d square X, second derivative, if you send this X to other side, d square X by dx square plus K square X equal to 0. One more thing, here is not a string. If you have a string, that means you had 3 different possibilities of the solutions. Here you have drum, that means always you are going to get the wave equation. Wave equation that is always in the form of sine and cosine like this, periodic function. And that's why I just ignore that first and last part for k equal to negative p square or like this, whatever we did. Just sine and cosine function, second solution. So x equal to c1 cosine kx plus c2 sine kx for this one. As I told you, for this y, I would like to consider another constant L. So d square y over dy square plus L square y equal to 0. So y equal to c3 cosine Ly plus c4 sine Ly. And this corresponds to k, this corresponds to L. So k plus L or k square plus L square, that is related to your t. So d square t over dt square plus k square plus L square c square t equal to 0. This c square is a additional factor. C square and t, capital T, both will go to other side. So that's why this is the additional factor. Okay, and the solution for this one, again, auxiliary solution is, this is the auxiliary solution, and the solution, that is capital T equal to C5, C1, C2, C3, C4 I've assumed. So C5 cosine this one, K square plus L square square root CT plus C6 sine K square plus L square CT. Okay, but my solution was U equal to XYT, this 3 product. Let me take the product of, let me take the product of all these 3, X, Y, and T. So this product will give you the solution. This is the solution. But now we have to add the boundary and the initial condition. So my boundary condition, if I consider this membrane just like this in this form, square form or rectangle form. So let's suppose that the membrane is rectangular and is stretched between the lines x equal to 0 and x equal to a, and y equal to 0 and y equal to b. Right? So x equal to 0, x equal to a, y equal to 0, that is the rectangular form. That means your boundary condition, what's the boundary condition? U equal to 0 when x equal to 0. U equal to 0 when x equal to a. U equal to 0 when y equal to 0. Right? And u equal to 0 when y equal to b. So that is your boundary condition. If you apply this boundary condition on your last equation, equation number 4, if you apply over here, u equal to 0, if you take u equal to 0, then this part is 0. X equal to 0, x equal to 0, cosine 0 is 1, so C1 is there. Sine 0, 0, everything is 0, 0, 0, so C1 equal to 0. So C1 equal to 0. So this factor will get cancelled out. If you take, if you take u equal to 0 when x is equal to a, so u equal to 0, x is equal to a. Already I said C1 equal to 0, so this is just gone. And x is equal to a. So sine of ka, C2 sine ka, right? 0 and C2 sine ka. You are going to get something like this. C2 sine ka equal to 0. And sine ka is equal to 0 means k equal to m pi by a. If you use the third condition, C3 equal to 0, third condition, U3 equal to 0 and y equal to 0. So this is 0. Y equal to 0, cosine 0 is 1, so C3. This part will be 0, everything is 0, so C3 will be this one. So C3 is 0. And same way we have L equal to n pi by b. If you plug all these blocks, 1, 2, 3, 4, over here in your solution, you're going to get uxyt equal to C2, C4, sine m pi x by a, sine n pi y by b, C5 cosine pt and sine pt, where p is given in this form. P is given, I just wrote it down, my L and m factor, this factor separately like this. This one and this one, m square by a square plus n square by b square. P equal to this one. Please keep in mind this thing. This is the solution. You're going to get C2, C3 like this. And so 4 becomes like this. 4 is like this with P equal to this one. And if you plug all this with replacing the arbitrary constant suitably, we can write my general solution uxyt, my first solution, that is equal to summation of sine m pi x by a, sine n pi y by b, n pi y by b, and this constant C2, C4, whatever it may be, C2, C4, and C5, that is suppose A, M, N, cosine of PT, and C2, C4, and C6, that is my B, M, N sine of PT. So using my all boundary conditions, I just got all my constants, everything. Now I need to figure it out. What is this constant AMN and BMN? Once I'm done with this A and B, means we are done with the solution. We are done with the solution. So if you write like this, look at here. Suppose the membrane starts from rest from the initial position. Initial position means f of xy equal to u, means when time t equal to. Now previously my conditions were like this. My t was constant, and I made the changes over here with x and y, because I told you x and y, they are completely independent. And that's why that was called the boundary condition. I did not change my x, I changed my x and y, but I didn't change my t. Now I'm going to change my t, and my x and y remain same. That's why it is called the initial condition. So u of f of xy, and that is u xy. See, my t equal to 0, it is u of f of xy. T equal to 0, u of f of xy. Okay. So del u by del t equal to 0 when t equal to 0. If you take del u by del t equal to 0, take the partial derivative of this one with respect to t. Partial derivative of this with respect to t. That means this is constant as it is. Partial derivative with respect to t means this will give you sine pt, some pa sine pt, and here it is cosine pt, right? Cosine pt. And if you take t equal to 0, this because this one is sine, it will go on. It will be gone. And here it is cosine, means cosine 0 is 1, so it is BMN. And del u by del t, my left hand side is 0, so my BMN is 0. So naturally this constant is 0. So this one is gone. Only I'm working with only this portion now. U x y t equal blah 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 up to here. That's the end. But I am looking for this AMN, and I will be done. Also using the condition u equal to f of xy when t equal to 0. So when t equal to 0, this portion will be converted to your function f of xy. This is as it is, this one is as it is, this one is as it is, this one is as it is. And as I told you, AMN, t equal to 0, cosine 0 is 1, so AMN. So AMN, right? Now guys, look at over here. Previously, we had just one summation. In the wave equation, one dimension, we had one summation. Here we have two summations. That means instead of one integral, we will be working with two integrals simultaneously over here. So this is a double Fourier series. That's why it is called a double Fourier series. You don't have any idea about the double Fourier series, and that's why I was a little bit hesitating to start this one, but I think we are not using double Fourier series a lot. It's just double integration. And there is one theorem that is called Fubini theorem, F-U-B-I-N-I. And Fubini theorem says that double integration f of xy dx dy is equal to integration f of xy dx times integration f of xy dy. So you can write dx and dy separately using Fubini's theorem whenever your function is continuous. Membrane wave equation is always continuous. There is no discontinuity in between. It should not be, right? So that's why we are using Fubini's theorem over here, multiplying both the sides of this equation 6, by sine m pi x by a, sine n pi y by b. Whatever the factors you have over here, just multiply both the sides by this factor, integrate. Continuous summation is nothing but the integration, because as I told you, you are working with the continuity, means your continuous summation. That means this portion itself will be converted to integration. Okay, your range of integration is x equal to 0 to a, y equal to 0 to b, because that's the range we have decided for my portion of the membrane, like this, x equal to a and y equal to b. Sounds good. Okay, so if you do this one, please keep in mind this thing guys. If you do this thing, so integration both the sides, multiplying first by these two factors, left hand side, right hand side, integrating with respect to this one and this one. Right hand side will be converted to AB by 4 and just constant. How to convert this one? Just I would like to leave it to you. Just work 3 to 4 steps and you will be getting AB by 4. If not, let me know. It's very simple. I can give you the hint. You are working with this one. AMN, that's the constant you are working with. Just take this constant, pull this constant out, and this is double integration. Here you have multiplied with sine m pi x by a, sine n pi y by b, the same factor you have multiplied here. That means you are making square of this one and square of this one. Agree? Good. Square of this one. You have multiple integrals over here. As I told you, multiple integration, one is m, one is n, that means x and y is there, so dy and dx, or dx and dy. Make these two integrals separate. Integration amn outside. Integration sine m pi x by a dx. Integration sine n pi y by b dy. And take the integration of sine is cosine, take the range 0 to a and 0 to b, and you will be getting this one. So just small little things I left for you. But I gave you complete. I just verbally, I spoke it the whole thing. Now you can just put this one in, just work for 3-4 lines, 2-3 lines probably. It's not actually required. You can speak directly to, and you are going to get AB by 4 AM. And that's why AMN equal to 4 divided by AB. Just if I send this one, if I divide throughout by AB by 4, it is 4 divided by AB, and this one, that is by AMN. And that AMN is nothing but this, oh, sorry, that is this AMN, or this AMN. Okay, so finally, we ended up with this one. AMN is this one, and that's why my solution is u x y t equal to summation m to infinity, m equal to 1 to infinity. AMN, sine m pi x by a, sine n pi y by b, cosine of pt, where this p is given by pi c m square by a square plus n square by b square. Only these 3 parts you need to memorize, or you just need to figure it out. AMN, this one and this one. Theoretical portion looks like little more complicated than previous 2-3 sections, but examples are way easier than the previous parts. If you look at the first example, you will be having the complete idea. Look at here, example number 1. A slightly stretched unit square membrane starts vibrating from rest, and its initial displacement is k sine 2 pi x sine pi y. Initial displacement means function itself is given to you, f of xy, sine 2 pi x sine pi y times k. So f of xy is given to you. So that the deflection at any instant is k sine 2 pi x sine pi y cosine of root 5 pi ct. Same, almost same thing, only you need to figure it out, this root cosine of this one, and this can be figured out with the help of your P. It's simple. Let's see. First of all, it's a membrane. Whenever membrane word is there, you are working with wave equation in 2 dimensions. So I just use this equation. Second thing, my boundary conditions. So boundary condition, look at here, tightly stretched unit square membrane. Just now I showed it to you, the unit square membrane. So 0 to 1, and here it is 0 to 1. Agree? So here it is 0, 0, here it is 1, 0, here it is 1, 1, and here it is 0, 1. Am I right? Am I right, guys? That is the unit square membrane. Yes or no?
Yes, sir.
Yes, sir.
All of you? Good. So, boundary condition, U0, suppose length is L. So, LYT, U. So first I keep my Y as it is. I just change my 0 to L, means I just work in the horizontal direction. So U0 to L. That is equal to, now I keep my y changing, I'm working from 0 to, say, vertical direction. So u x0t, u xt, that is equal to 0. My boundary condition. My initial condition is, as I told you, initial condition means now I'm working with just my t. So xy0 as it is, that is equal to my function. My function itself is given to us here is because the initial condition is given to you in the form of the function uxy time t equal to 0. Initial means time t equal to 0. And f of xy is k sine 2 pi x sine pi y. Exactly same as given in the theoretical portion. And del y by del t equal to 0 when t equal to 0. Right? Del y by del t equal to 0 when t equal to 0. Let's start with this one. Look at here, guys. Ready-made solution for my membrane equation means two-dimensional wave equation, ready-made solution. U, X, Y, T, we know this thing, where A equal to B equal to 1, right? Because it's a unit square. So here in my solution, I have A equal to B equal to 1. So my P equal to pi C, M square by A square, N square by B square. But A equal to 1, B equal to 1, so just M square plus N square. Agree? Yes or no? Yes or no? Guys, are you getting me?
Yes, sir.
Yes, sir.
We are.
Okay. Now, so I have just fixed this one. Just look at this definition as I told you. PC M square by A square, unit square means A equal to 1, B equal to 1, N square by B square, right? And then after, now f of xy, already we fixed your f of xy. That always comes through your initial condition, always. So uxy 0 equal to f of xy equal to this one when t equal to 0. And derivative is 0 is 0. Derivative is 0 because this is constant, so it is 0. Okay. And AMN, as I told you, that is given by AMN 4 over AB, but A and B are 1. So 1 and 1, integration 0 to 1, 0 to 1, f of xy, just now I told you, k times sine 2 pi x, sine pi y, sine m pi x by A, sine n pi y by B, and dy dx. Agree, guys? That should be my AMN. Agree? Agree?
Yes, sir.
All of you?
Yes.
Yes, sir.
Yes,
Yep.
sir.
Good.
Sir.
Thank you. Now, 4 divided by 1 times 1, 0 to A means 1, B is 1, f of xy is this one, sine m pi x by A, but A is 1, and pi x by B is 1, so this one. Don't you think, see, actually, yeah, I didn't want to give this calculation, but then after, I just changed my mind. Okay, look at here. What I did, as I told you, I have used the Fibonacci theorem over here. If you use these Fibonacci theorems over there, where I left those 3 lines for you, same thing, 0 to 1 and 0 to 1. So I just wrote it down, this 0 to 1, this integral for x times this integral for y. Integral, this integral for x. K is constant, pull it out. Sine 2 pi x and sine m, my bad, sine 2 pi x and sine m pi x over here. M pi x and 2 pi x here. Sine pi y and sine n pi y over here with respect to y. Agree? How can you solve this integral? Divide and multiply it by -2. Why -2? Because s and s is there. So -2ss equal to c minus c. Formula sheet, second page, middle part, below unit square, right side. You know, c plus c is equal to 2cc, c minus c is 2ss, c s minus, I'm sorry, s plus s is 2sc, s minus s is 2cs, c plus c is 2cc, c minus c equal to -2ss. Am I right? Yes or no, guys? Fourier series?
Yes.
Whew. Okay, so that's what I did. Just for the integration, divide and multiply by -2. So -2 sine m pi x, 2 pi x. That means -2 sine m pi x common. So m plus 2 and then m minus 2. So -2 ss is c minus c. Cosine m plus 2, cosine m minus 2. And integration. Integration cosine is sine m plus 2 pi x by m plus 2, m minus 2 pi x by m minus 2. Same here. But everywhere you can see over here, actually my integration starts from 0 to 1. So I don't bother about -2 point. Actually, m is not equal to -2 here, m is not equal to 2 here. M is not equal to 2 bothers me because that is within the range of integration. So I have to put the restriction, my m is not equal to 2. I don't bother about -2 because that's out of integral. Same here, n plus 1, so n equal to -1, forget it. N equal to 1, yes, n should be different from 1. And because range is 0 to 1, and sine m plus 2 pi x, if you replace this x by 1, so m plus 1 and pi. If you take m as any integer except 0, suppose 1, so it is 2 pi, 3 pi, 4 pi, 5 pi, because of sine, everything is 0. Same here, same here, same here. If it is 0, sine 0, sine 0, sine 0, everything is 0, except m is not equal to 2 and n is not equal to 1. Agree, guys? its situation is slightly different than your Fourier series. It is the part of Fourier series, but in Fourier series, what we did, we counted for these values where function is not defined. Are you getting me? And we got some values over here for this one. Here, we are getting 0, and we are going to count separately for this m equal to 2 and n equal to 1. But what m equal to 2? M equal to 2 means this a2, and any a equal to 1 it means a21. That means for your square membrane, only a21 will come into the picture. All other things will disappear. Now all other constants will be gone. Just a21 will be there. Let me just count my a21 over here in the same formula. So a21 will be like this. A21, 4k, 0 to 1. Integration with respect to x, integration with respect to y. Sine and sine, same angle, sine square. Same angle, pi, sine square. Sine square can be written, oh my god, sine square can be written as 1 minus cosine 4 pi x. 1 minus cosine by 2, right? Again, formula sheet, page 2, trick formulas. Integration, x by 2, sine 4 pi, x by 2, 1 and 0. So this part will be 0. This part will be 0. Only 1 by 2 and 1 by 2 in between product. 1 by 2 and 1 by 2. 4 will get cancelled out. Only k is left out. So my PC is equal to pi c square root of. What is my m? What was the formula? So my a21 is fixed now. A21 is k. A21 is k. And what is my p? My p is pi c. M is 2. 2 square. A is 1. 2 square divided by 1 square. So 4. N is 1. B is 1. 4 square plus 1 square. 5. Square root of 5 PC. That's what is asked to you. Square root of 5 pi PC and cosine function. And that's why your solution is, my PC is this one. My solution was UXYT. Just plug whatever you figured it out, A21P, plug the values in your general solution. So general solution was this one, UXYT. Number 2, UXYT equal to summation AMN. So plug the value here as it is. Plug the value m equal to 2 here, n equal to 1 here, cosine P, plug the value P here, and you are done. Plug the value P here, and T as it is, root pi P, root 5 pi C, and T was as it is. So that is a solution. Simple. You need to pay attention, not pay attention, just memorize the things or take the help of only these formulas. AMN, general solution, where AMN is this one and P is this one. That's it. Right? You'll be more happy if we go over the next example.
Sir, is this PDF on your Canvas?
It is already there.
P5.
Is it there? Just check it. I think.
I don't see PDE5 on your
You
files.
don't see PD5?
No.
I will do it right now. I mean to say right after this example. Okay. Just
Sounds good.
thanks for reminding me. Find the, now look at here, guys. Same example, same theme. I told you examples are quite simpler than the other part. Find the deflection U, X, Y, T. Previously in one dimension, we had just UXY or UXT, UYT like this. Here UXYT. Find the deflection UXYT of a rectangular membranes. Rectangular membranes means 0 is less than or equal to X is less than or equal to A, and 0 is less than or equal to Y is less than or equal to B. A and B are different. If they are same, it's a square. Whose boundary is fixed. Boundary is fixed means 0 to A and 0 to B. Boundary is fixed. Given that it starts from the rest. Start from the rest means time t equal to 0. And uxy0 equal to, function is given to you, f of xy is xy minus and b minus y. Exactly same as the previous one. Exactly same as the previous one. Okay, let me do one thing. Before I go for the solution, look at these last two problems. Find the deflection uxyt of a square membranes with a equal to b equal to c equal to 1 if the initial velocity is 0, del u by del t equal to 0. initial velocity when t equal to 0. And the initial deflection function is given to you. Initial deflection function is given to you, right? Function is given to you means what will happen over here? You get here a equal to b equal to c equal to 1. If the initial velocity is 0 and the initial deflection f of xy equal to k sine pi x sine 2 pi y. Don't you think this example is exactly same as the first one? You get the first example again. K sine, here it is 2 pi y, 2 pi x sine pi y. Sorry, here. It's exactly same as. Look at this one. This is the answer actually, right? This was the answer. Because so that is given. That's why this was the answer. Let me look at the answer of this homework example. Answer of this example. uxyt k sine pi x, k sine pi x, sine 2 pi y, sine 2 pi y, cosine of root pi 5t. Don't you think this example is exactly parallel to the first example, whatever we went through? Yes or no, guys? Yes or no? Please say something, please.
Yeah.
Yes.
And
Yes,
that's why 6 examples already I posted on Canvas for you guys. But if somebody wants to pick any one of these 2 examples, that would be counted as my 7th example. Choice is yours. First come, first serve. Somebody wants
So how do you, like, are you gonna let us know when a problem has been claimed, or are you gonna assign the problems to us, or how do you expect to do
I'm
that?
not going to assign the problems to you. I told you I think you were a little bit late, but I only told you that you guys need to take the problem by your own, by the mutual understanding. Once you are taking the problem, just send a message to other guys that I'm picking up this problem. So please don't take this problem. That is my problem now. Suppose Daniel is taking the problem number 5. That means now 5 is gone. All other guys will try to pick up the problem from 1 to 4 or 6 or any one of these 2. Because 5 is gone like this. So it is up to you. And that's the reason I posted the problem yesterday. At least you will look at the problem. And yeah, you need to present this one. You have to present this one day after tomorrow. Just one example, 10 minutes, not a big deal. And everything, because I'm sure you guys have gone through almost the application homework problems. And this is just similar to them, not exactly same, but just similar to them. So that's why that won't be a big deal for you, because already you guys have worked separately without taking any help. So it won't create any problem for you. So if it is possible, I can recommend one thing to you. After our class, you guys can meet just for 10 minutes, discuss in between on Zoom or like this. You can meet on Zoom or you can meet on Skype, whatever you decide, and discuss the problems. And then after, take your choice. I think that is the right way to pick the problems. Because if somebody is picking the problem in the absence of other guys, in that case, it's a confusing part. So I would suggest you to pick up the problem when all you guys are together, when all you guys are there online.
We should do that right now.
Suppose as per example, suppose Blaine or Zach, he wants to take number 4, or Jennifer, she wants to take number 5 or number 4, and Zach says, no, please leave this problem for me. And suppose she said, okay, that's fine, you can take this problem, I'll pick another one. So I think that's the right way to pick the problem. Is it okay?
Is it all right if we just ask, if we organize this at the end of class, like after you're done? If we just use this Zoom meeting since we're already here?
Okay, so you want to take the problem in my presence, right?
I mean, we're already here right now, so we might as well do it.
That's fine. I don't mind. That's fine. That's fine. Because I'll be done in next 10 minutes. So then after we can spend the time for this one. Sounds good.
And how about and for everyone's sake, I'll just create a Google Doc. I'll write down what everyone picks and I'll create a Google Doc and share it in case anyone forgets who has what.
Okay.
Sounds good.
Sounds good, yep. Okay, guys, now look at the second problem too. Just read this problem. Read this problem. Before I start the solution of the second problem, just read this homework problem. Find the deflection UXYT of a rectangular membrane. Rectangular membrane. 0 is less than X is less than A. Instead of A, here it is 1. 0 is less than Y is less than D. Here it is 2. Whose boundary is fixed. Lines are also same. Given that that it starts from the rest and UXY0 equal to, my function is almost same. Look at here, it was A minus X, B minus Y, because my A and B are 1 and 2, so 1 and 2. That's it. Just parallel. Am I right? Yes or no, guys?
Yes. Yes.
Okay, now let's go through. See, it looks like answer is really very big, looks awkward. I do agree with you, but actually when you solve this problem, it's the simplest one compared to other parts. So anyway, let me go. I don't want to speak anything right now, but let me just go through the second solution. Again, let me read the problem. Jennifer, read the problem.
Find the deflection U of XYT of a rectangular membrane where X is greater than or equal to 0 and less than or equal to A, and Y is greater than or equal to 0 and less than or equal to B, whose boundary is fixed given that it starts from rest and U of XY and 0 is equivalent to XY times the difference between A and X and the difference of B and Y.
Right, guys?
Oh, and
yeah, XY minus X and B minus Y, that's fine. Okay, guys, look at here. Now, then that's the reason why I read that problem, homework number 2. Look at here, it was 1 here, it was 2 here, it was 1 here, it was 2 here, lines are same. So if you make the corresponding changes over here, you can solve this problem in 3 minutes after this one. Right. Okay, let's go through this one. Again, see guys, theme is same. My UXY general solution is given over here, m equal to 1 to infinity, summation n equal to 1 to infinity, amn sine m pi x by a sine n pi y by b cosine of pt, where p is given by pi c square root m square by a square plus n square by b square. And amn is given by 4 over ab. I just wrote down all the things which I require. First, 4 over ab, 0 to a, 0 to b. My function f of xy is given to you. Xy, a minus x, b minus y, sine m pi x by a, sine n pi y by b, dx dy. Right? And I'm first counting this one, amn, and then after I will fix my boundary and all this condition. That's easy. Okay. So amn, actually, you don't have to fix everything, boundary, and because boundary and everything that is fixed over here in the solution itself. So you don't have to go through it. Just find amn and p, that's it. So amn equal to 4 over ab, 4 over ab. Okay. Yeah, here it is a and b. In that example, it should be 0 to 1, 0 to 1, 0 to 1. A and b, 1 and 1, so 4 over 1 and 1. I don't want to say anything more. That's fine. Now, this is my function sine Fubini's theorem, multiplication, I mean the integration with respect to x and then y, separate integral, u into v rule, Fourier series, u into v, u into v. So u as it is, integration of v. And then, of course, it looks little bit big expression, big in terms of like this. Otherwise, it's, see, this is my u. Integration of sine m pi x by a is negative cosine m pi x by a divided by constant m pi by a, m pi by a. Minus sign, alternating sign, derivative of first, x a, derivative is a, minus x square, derivative is 2x, a minus 2x. Integration of this part, so m pi by a as it is, and this integration negative cosine is negative sine. And one more m pi by a again here, so square. Derivative of a is 0, signs are alternating, so now it is plus. Derivative of a is 0, x minus plus, derivative of 2x is 2, plus and, sorry, signs are alternating. Derivative of a is 0, negative 2x is negative 2, sine is cosine, and here it is cube. And my range is 0 to a, agree? And exactly same factor, see, that's why I put the multiplication. Exactly same for here, and that's why I have, it looks little bit big expression like this. y minus yb minus y as it is. Integration of this one. Derivative, integration, derivative, integration. And stop. Why I stop here? Stopped here because -2 derivative will be 0. So that's why I stopped here. Same here. -2 derivative, next derivative will be 0. You need to stop. You need to stop here. 0 to b. Okay, 0 to b. 4 over ab. 4 over ab. Let me just go back. Oh, I'm sorry. Let me go back. What will happen over here, guys? 0 to a. If I replace by a minus a is 0, right? So this term will be gone. Sine m pi a will get cancelled out. M is integer, sine integer, pi, 2 pi, 3 pi, 4 pi, 0. This term will get cancelled out. -2 cosine m pi a. Cosine m pi is -1 to the power m. And m pi a over cube means a over m pi cube over here. So -2 a cube over m cube pi cube here. Sine m pi is -1 to the power m. Now 0. X is 0, term is gone. 0. Sine 0, term is gone. 0. Cosine 0, simply 1. So this term is, this part is 1, -2 m pi over a cube. That's for first one. Exactly same for the second one. And I'm getting like this, -a cube m cube pi cube, as I told you. Cosine m pi, oh, I wrote it down. It's not required. Directly you can write -1 to the power m. Okay. And for second term, I just wrote it down. This term first. See, a cube, 2, m cube pi cube common. Same here, b cube common. And then here nothing is left out. So 1 minus sign is there. 1 minus cosine m pi -1 to the power m. 1 minus -1 to the power n. If m is even, what will happen? 1 minus 1 is 0. Everything is gone. If n is even, what will happen? Everything is gone because 0. Agree?
Mm-hmm.
M or n. M, I put the word or. M or n even, everything is 0. If any one of these is even, both are even, everything is gone. But suppose both are odd. Here it is 3, here it is 3. -1 cube, negative, positive. So this is 2, 2 2s are 8. Agree? 8 2s are 16, 16 2s are 32. Am I right, guys? Yes or no?
Yes.
And multiplied by 4 and divided by here also. So you are going to get, if you simplify this one, you're going to get 64 a square b square over m cube, n cube, m cube, n cube, and pi to the power 6. If m and n both are odd. So I fixed my AMN. I fixed my AMN. AMN is fixed, and hence the deflection of the rectangular membranes given by 1 is AMN 64 a square b square, this one, and p equal to pi c m square by a square, because a and b are as it is, a square b square, and this one. So that's it. Here, if you compare this solution with 2, with your homework problem 2, only difference is a equal to 1, b equal to 1, m equal to, my bad, a equal to 1, b equal to 2, right? A equal to 1, equal to 2, and what's the other difference? And the function here, 1 and 2. So that's why you are getting some AMN equal to 256, something like that. And that makes sense too, because if you write, let me just count it. If you write, where is it? Yeah, 2 and 2, 4. 4 2s are 8, and 2, 16. 16 4s are 64 over here. Okay. So 4 2s are 8, 8 2s are 16, 16 and 2, 64, 64 and 2, and here you're going to get one more. Okay, so 64 multiplied by 4, 64 multiplied by 2 is 128, 100 multiplied by 2 is 256. Okay, that's why you're getting 256. Makes sense. So 256. And I just put the line. That's the end. I don't want to go through that transmission line. I think that's fine. We did enough things. Only thing is, now take a problem. Start.
Just to clarify, the one that for problem number 7, that would be number 1 for this homework since we just went over number 2.
Problem number 7 is any one of these two. Yeah, pick one. If you want to take, okay, go ahead.
Oh,
What?
also, for anyone, you'll find the other 6 problems on Canvas. You open 1.jpg and 2.jpg.
Yeah. Yes, it's already on Canvas.
I'll take the first one on the first JPEG.
All right. Let me write that down. and
Jennifer,
I'll
please
send you all the
keep
links once
the record, please. Who is
I'll
taking?
take the second one.
Okay, let me write it down.
Okay.
Let me write it down. Who took the first one?
Oh, that was Richmond. She took the first, and then Daniel's taking Dante's taking the
That's-
second.
Let me write number 1, and then number 2 is
Daniel.
Daniel. Okay.
And that's wave equation, one dimension, the second one.
Yeah, I gave the number. I gave the number 1, 2, 3, 4, 5. So what? Number 3. Number 3.
I'll take 3.
Oh,
And
Zach.
that was okay.
Zach.
Right. Yeah.
Okay. Number 4. Blaine, Mike, Fleming.
I'll take number 4.
Give me 6, sir.
Okay. Jennifer, Gennifer. Okay. And Fleming, number 6, right?
I guess, sir.
Okay. Fleming, number 6. Then,
How about 5, sir? I'll take 5.
who, Blaine?
No, Mike. I'll take 5.
Oh, I'm sorry. Okay, Mike. Okay. Mike, number 5. And nobody wants to take this one. Right? This one is the easiest one. I thought that probably any one of you would have picked up this one very the first day anyway. Which one? First, out of these 2 problems in front of you, that is counted as 7. Either 1 or 2.
Do the second one.
Second one?
Yes, sir.
Okay, Blaine, that's a good choice. Actually, both are good choice. I thought that probably people will choose this one first. Anyway, so Blaine. Okay, number 7. Blaine. So everything is done, and next time we are going to start the presentation one by one. We will start with number 1, 2, 3, 4, 5, 6, and 7. Make sure if you are done with your turn, that doesn't mean that you are allowed to leave the class. No, you have to stay here until the last guy is done. Please make sure this thing.
Is this what our final technically is?
Yes, that's what people have decided.
Okay, sweet.
And I'll send out this list to everybody just in case you forget. But that'll take me a few minutes to get the name,
So nice of you.
the
So
email
nice of
addresses off on Canvas.
Good. So nice of you. Thank you, Jennifer. Yes, guys. Yeah, you are doing really good job, and I really appreciate all of you. I have one problem, guys. Some of you guys have not submitted your last homework so far. What's the reason? I already extended the date. Have you checked the date? I did not check the Canvas yesterday night, but Mike, did you submit your homework? Mike.
Yes, sir. I submitted it yesterday.
Yesterday, right? And Daniel and they already submitted. Daniel and
Yeah, sir. We submitted for
yes,
last
yes,
Saturday.
yes, yeah. You submitted zip folder. I know. And Zach,
Yes, sir. Sir, we turned that in.
no, you are with Daniel, right? I mean, yeah, Daniel and
No, I'm with Mike
always
and Blaine.
always I'm making mistake. Yeah. So Mike has submitted. Okay, got it.
We all turned it in.
Yes.
There.
No, actually, Jack, you submitted, but Blaine and Mike, they did not.
Well, their work was with all my the one email I sent you had all our work. submitted.
I know, but only you can see your grades. I cannot enter the grades without submission. So they have to submit the same file to get their grades. You know what I mean?
Okay. All right. Gotcha.
If you have, the system says like this, if I have a file, only I can grade the given file. I cannot grade the empty file or no file, right?
Gotcha. All right.
Yeah, so Blaine, did you submit it? Did you submit to Canvas?
Yes, sir. I submitted it yesterday.
Sounds good. I did not check it. I have not checked it, but I will do it very soon. So please do this thing. Make another thing is your last submission that is on Thursday. Please check the time. I think it is 11, night 11 something. I don't know, but just check it and make sure that you have to submit your homework assignment on Canvas. On Canvas, all of you, please, without fail. And just like your previous assignment, this is the application. So please go through this one and you will be done by day after tomorrow, right? Day after tomorrow night, you will be done with this course.
Sounds great, sir. Thank you.
Thank you so much for your patience, for your cooperation. I really appreciate you guys. One more thing, I think Daniel, he reminded me to put that PDF file, right? So let me, what is this?
It's a good question.
See? Oh my gosh, what is this?
Sir, I think you actually accidentally highlighted or something.
Yeah. Oh, yes. Yes. How can I remove this thing now?
Oh,
it's gone.
Oh, now there's a heart.
What's going on? One heart is there. Oop.
Sir,
Let me close this file now. Right? Zoom has stopped a share window. Okay. Just guys, wait. Let me first add this file to your what we say, Canvas, right?
yes.
This one too.
Are we good to leave the meeting, sir?
No, just wait.
Okay.
For 5 minutes, please, or 2-3 minutes. Where is it? Yeah, it's here. It's here.
So, sir, you said we could use internet libraries for like,
I'm not getting you. What is it?
I said, sir, you said we could use internet libraries at the beginning of class for these problems.
Your voice is getting echo. I don't understand you. If somebody else can speak the same word, same sentence, please.
Sir, Garner's wondering, we're allowed to use the internet, correct?
Oh, yes. Yes.
Okay.
Just wait, guys. Let me first submit this one.
And for our presentation, do you want us to like scan the file and then like share our screen and present it that way, or how are we supposed to?
Yes. You know, I just scan these files and then after I share my screen, the same way you have to share your screen so that I can look at your work over here, and you have to just move the cursor and you need to explain like that.
Okay.
Before that, our class starts at 2:25. Before 2:25, all you guys, please submit separate file. Please submit your presentation. Presentation means your solution, not the presentation actually, your solution in my email or Canvas, whatever is good for you.
Also, I'd just like to mention that I just sent out the link to the document with the names on it. So if anyone can check to make sure they got that, or
Good.
if it, you shouldn't be able to edit, but you should be able to comment if there's a problem.
That's good. Let me add this one now, assignment. So it's not assignment, right? It's everything is there on syllabus, right? Yeah, PDF. Okay, let me add it over here. Add it and files and upgrade and choose the file. Okay, and I want PDF 5, right? I want PDF 5. And let me go through upload. Okay. What PDF or wise? and update syllabus. And let me go to home and publish this one. Publish and publish. Course was. Guys, can you see PDF 5 in your Canvas syllabus? Canvas 471 syllabus. Please check this one, please.
I'm looking.
Yeah, please.
Where would it be? Where are you trying to put it?
I put it on Canvas and then course 471 and syllabus.
PDE 5?
PDF 5, yes.
I do not see it.
No. I did this thing in Zach because Zach is in the separate class. So Zach,
Oh, never mind.
Zach, please check it. I'm doing for you guys too.
Email.
Yeah.
Not seen anything for the whole for my class yet.
You are not getting so far? Zach? Are you sure?
So we're looking for the PDF 5.
Yeah, PDE 5.
Yeah, I got that on Canvas.
You got on Canvas. Good. And why? What's the reason here? These guys are not getting. Wait. Okay, PDF 5, it takes some time. Okay, that's the reason. Update the syllabus. Update the syllabus and let me publish this work. PDF 5 is there. Okay. Guys, please check. All you guys, please.
I see it now.
Okay, very good.
I see it too.
Very good. Good, guys. Everything is done, right? Successfully. Only thing is now, from my side, it's done. Now it is your part.
Yes.
Submit your last assignment homework and your presentation work. Means just one example. Just submit this one. Or you can do one thing. You can submit your last example. I mean, the last assignment and the last page. In the last page, just one file you can submit day after tomorrow. That's the due date.
Mm-hmm.
One file you can submit. Once you submit your assignment, last page you can write, or last couple pages you can write for presentation or presentation problem. You can make the title like this and then just send everything to me in one file on Canvas.
Sounds good.
Right? That will be easier for you too. Am I right, guys? Zach?
Yeah.
Jennifer? Fleming? Daniel?
Yeah.
Dane?
Hey, sir. Yes.
All good.
Fleming?
all
Good.
Oh,
Good.
yes. Yes, sir.
Very good. Valenzuela, Mike, are you okay?
Yes, sir. I'm on what you're drawing.
Good. Any question for me, guys?
No, sir.
Thank you so much. I really appreciate you guys. If you
Thank
have
you,
any
sir.
questions, still I'm open. Just send the email to me and I will try my best to get back to you very soon.
Sounds great, sir.
Thank you, Daniel.
Sounds
Thank
great.
you. Thank you, guys. Thank you.
Thanks.
See you day after tomorrow, in between, anytime, email, right? Take care, guys. Stay safe, stay healthy, stay happy. Bye.
Sir.
right, thanks, sir. See you later.
See you later. Yeah.
Sir.
Yes, question?
Yes, sir. I had a question on one of the problems from the homework.
Which one? I don't have it with me right now. Okay, go ahead. Which one?
It was from assignment number 6, and it's problem number 5. It's a.
I don't have it. Can you please speak the problem for me?
Just.
Please speak the problem for me. Yep.
Okay, sir. So number 5 is. Can you see
Assignment
my
6, you said, right?
Yes, sir. Problem number 5. It's this one here.
Assignment number
5 is right here, sir.
Okay. d minus d dash minus 1, d minus d dash minus 2 is equal to e to the power 2x minus y plus x. Yeah, what's the problem? It's a non-homogeneous equation. It's a non-homogeneous equation. So d minus, you know, d minus a d dash, sorry, m d dash plus a, and d minus, yeah, is that type of problem. Go ahead.
Yes, sir. So I got, I'm not sure if you can see
Okay,
that.
okay. So your A1 is 1, correct? And your A2 is 2. So roots are real and distinct. So e to the power on f1 y plus x plus e to the power 2x f2. Nope. Nope. Why it is y plus x and y plus x?
Should be.
What is your m? Y plus mx, right? What is your m? Just show it to me. Show me the problem.
M is both positive 1.
Both m is 1. Let me look at the problem. M1 and M2 both are 1, right?
Yes, sir.
Oh, then I think you are right. Okay. So that's correct. And then your right hand side is e to the power 2x minus y plus what? I think we are missing something. Plus e to the power 2x minus. What is the problem? You are missing
I'm
the
just
right.
confused. Yes, sir. So I'm missing. I got the first PI for e to 2x minus y. So when
second one is, what is second one?
That should be x on d minus d dash.
Oh, x means you have to convert your problem in terms of that Taylor's polynomial 1 plus x to the power negative 1 or 1 minus x to the power negative 1. Am I right? Yes.
I'm a little
Whenever you are, I think,
yes.
show me a solution. I think you are getting confused at that.
That's the part that I'm getting confused at.
Oh, I got it. I got it. Okay.
Yeah. So right here, that's one. Okay. Right when you take x.
Okay. Just show it to me. Show it to me. 1 over.
Should
1
be
over d minus d dash minus 1, and then d minus d dash minus 2 and x. Agree? Okay.
Yes, sir.
That is equal to, see, I am writing like this, d minus d dash minus 1 and 1 over 2 common. So 1 minus or minus 2 common. So 1 minus d minus s and x. That is equal to 1 over 1 minus 1 common. So 1 minus d minus d dash. And here also 1 over negative 2, 1 minus d minus d dash and x. That is equal to 1 by 2, this minus and minus. It should be like this. Look at here.
I'm not sure if I can see that, sir. Would it be possible, sir?
Did you get my ring?
Yep. And so far,
whenever you have some algebraic function like this, x squared like this, always convert that is in the form of 1 over 1 minus x or 1 over 1 plus x.
Okay.
You got
and
it.
That is
No, you got the file.
Yes, sir. I got it right here.
Yeah, look at that one. Now we'll discuss.
Okay, sir.
See what I did. I just took both the products separately. Oops, where I was. Yeah. Both the products separately. Then first part, I will say d minus d dash minus 2. I took negative 2 common. Why negative 2 common? Look at me, please. Why negative 2 common? Because if I take negative 2 common, inside I am getting 1 minus, I put the bracket, d minus d dash. Agree?
Yes, sir.
That is of the form 1 minus 1 over 1 minus x form. Agree?
Yes, sir.
1 over 1 minus x. Right? Negative 2, I can pull it out. And that's why I cross that line. Negative 2, I can pull it out. Agree? So what is left out inside the bracket? 1 over 1 minus x, 1 minus d dash and x. What is the expansion, Taylor series expansion of 1 over 1 minus x? 1 plus x squared plus x cubed and so on. But you have just one derivative, x. So 1 plus x squared, right? So 1 plus your x is d minus d dash. So 1 plus bracket d. You want me to write it down? You
If you could, sir, just so I can see the process.
okay, no problem. So
I couldn't. I was
1
really
over
just
1
confused
minus
following
x
the
cube 1
examples.
plus x square plus x cube and so on. 1 over 1 plus x equal to 1 x plus x square minus x cube plus x to the power 4 and so on. So 1 over 2, 1 minus d dash, 1 over 1 minus d dash, 1 minus d dash. If I take this common, I'm going to get, I made a mistake. It is in the new file, which I'm going to send you. It is corrected now. I take negative 2 common. Okay, that makes sense. And d dash by 2 and x. That is equal to 1 by 2, 1 over 1 minus d dash. Here it is 1 plus d minus d dash plus d minus d dash square plus so on and x. That is equal to 1 by 2, 1 over 1 minus d dash. And here it is x plus derivative of x is 1. And that's it. Now look at here, see. I think you will get everything now. Well, let me solve the whole problem. I think that will be better. That is equal to 1 by 2 inside the bracket 1 plus d minus d dash square divided by 2. Okay. So 1 by 2 derivative of x is 1. So 1 by 2. D minus d dash, that's this dash, and x plus 1 by 2. That is equal to 1 by 2 and x plus 1 by 2 plus derivative of x is 1. 1. Yes, derivative of x is 1. So here it is 1 and so on. Yes, you can work in this direction. Let me send another picture to you.
Thank you, sir. Sir, so I have all of your notes from before we went to online class and after we went to online class. And I think you told me that you wanted these saved. You want me to bring this in August and I can just give you this binder?
Yes, thank you.
Sure.
Thank you.
Yes, sir, no problem. It's kind of interesting, sir. So I'm a double major, physics and
physics and math. And this one is, 4-year series that plenty of applications in physics. In optics,
yes, sir.
You must have gone through optics. Then what is the another branch of physics?
E&M, electricity and
electromagnetics.
We actually, so last semester before I was in this class, I had to teach myself how to use Laplace's equation.
Oh, okay, good.
Yeah, so now that I've kind of seen it again, it's not too bad.
Yeah, you got that file. You received it.
Let's see.
Now see, let's discuss these things. See, I wrote it down everything. If you read this one, you will come to know everything now.
Okay.
Make sense?
Yes, sir. Thank you.
No problem. Shall we stop here?
Any more questions? Thank you.
Okay.
So far so good. I've made it up to assignment number 8. So
okay.
And that's where we use the boundary conditions. So I may send you an email later, but so far so good. I've been able to get them all. This is just the one I couldn't. So.
Thank you. Thank you so much.
Thank you, sir. Have a good day.
You too. Thank you. Stay safe.
Bye.
Bye.